Everything we've done so far has been relatively static. Let's start exploring a whole new world of interaction. We'll be making this mouse follower program that follows the mouse around with a circle, and then when you click on it, the circle becomes a random color. This is kind of a toy example, but it illustrates some important key concepts for building interactive graphics and data visualizations. I'll start by forking circles with D3, and I'll call this mouse follower. The idea here is just to make a first interactive program that draws a circle where the mouse is, and then when we move the mouse around, that circle should follow the mouse. Over in index.js, let's make it so that there is only one circle. Now let's set up some code that gets notified when the mouse moves. We can do this by setting up what's called an event listener. See, every time you move the mouse or click, or a lot of other things, type a key, there are these things called events that get triggered in the page. And we can catch them or intercept them by listening for them with event listeners. Because I want to be listening for when the mouse moves, we can add a mouse move event listener to the SVG element. And we can do that by saying .on mouse move, passing a function. And just to see if this works, I'll say console.log mouse moved. And then when I move the mouse, sure enough, it gets logged out. It says mouse moved. All right, that's how you can add an event listener with D3. We know the mouse has moved, but we do not know where the mouse was when it moved. To find that out, we can access the event, which is an object that has a number of fields on it. See here, it's a mouse event that has all this stuff, including client X and client Y. There's also layer X and layer Y, page X and page Y, screen X and screen Y. It's always kind of confusing to figure out which properties to use, but luckily D3 has a utility for extracting the right kind of coordinates from these events. This is discussed in the documentation for D3 selection. We can use this function called pointer and just pass in the event to get at the X and Y coordinates that we need. Let's try that. Let's pass our event through the pointer function, which we need to import from D3. Now when we move the mouse, we get these coordinates. All right, that's how you can use D3 pointer to get at the right mouse coordinates. Now let's use those to position our circle. There are a million ways you could add interaction, lots of ways to approach structuring the code, but I personally am a huge fan of unidirectional data flow. This is a pattern popularized by React where the state of the application lives in one place. And then when the state changes, everything re-renders based on that state. And that's the pattern I'd like to use here. This diagram sums up unidirectional data flow. The system renders something on the screen, and then the user interacts with that thing on the screen. And that interaction triggers a re-render of what's on the screen. Technically, what happens when you interact is it triggers an event listener for some kind of interaction event that gets fired or emitted. That event listener is then responsible for changing the state or updating the state. In response to changing the state, the system renders an updated version of what should be on the screen using idempotent rendering, which we'll discuss later. You know, I really love this model because the person, the user, the viewer, fits into this model. When something is rendered on the screen, perception and cognition take over. You see what's on the screen, and then you can think about it, and then that translates to volition and action. And this is all taking place inside of a human being. So the human is literally in the loop. That's unidirectional data flow in a nutshell. Let's apply this pattern now in our code. We can do that by leveraging these options that are passed into the main function. State and set state. State is an object that contains the state of things, and set state is a function that we can use to change the state. And when we call set state, main gets invoked again with the new version of the state. So let me say console.log state and see what that is initially. All right, it's an empty object. The x and y position of the circle are going to live inside of this state object. And so that begs the question, what should the x and y position be initially? I would say let's put it in the middle. So we can say if state.x is undefined, then let's call set state. And set state actually accepts a function that returns the new state. So I can say return an object that has x defined as width over 2 and y defined as height over 2. And because the code down here will depend on state.x being defined, in the case that it's not defined, I'm just going to return out of this main function because it's going to come around again with state defined, and then it'll get through that. So if I run this, oh, nothing happens because the data for our circle is hard-coded here, but x can be defined as state.x, and y could be defined as state.y. Now when I run it, it appears in the middle. Okay, that's how we can initialize the state. Now let's change the state as the user interacts. This pointer function returns an array of two elements, x and y, which we can destructure into an array right here. And once we have that available, we can call setState and pass x and y as the state, like this. Now when I move the mouse, it actually follows the mouse around. All right, that's how you can leverage the concept of unidirectional data flow to make a mouse follower. Let me make this example a little bit more complex to highlight what's called immutable update patterns and why they're needed. Let's say that when I click, I want the circle to change color. Let's try doing that by saying .on click, passing a function that invokes setState with some color. And I'll just make that a random color. And random color can be defined as this thing here, which the AI just generated. And let's also handle the color being initialized over here. So on the initial state, color can be whatever this one is right here, just blue. All right, so that color goes there. And then the fill here can be defined as state.color. So now when I click, nothing seems to be happening. Let me console.log our random color. Oh, we just need to put a hash in front of it. So hash plus random color. Okay, I think the random color is now correct, but look what happens. When I click, the circle goes to the middle and becomes blue. That's because we are clobbering the existing properties on the state object. We're actually defining the state to be a new state that doesn't have x or y defined. because we're returning this object here that just has color and not X or Y. And so this case is getting triggered over here, where state.x is undefined. To fix this, we can leverage the fact that this function takes as input the previous state. And we can return an object that has all the properties that were on the previous state by using this rest and spread operator with the 3 dots. What this will do is it'll create a new object and then assign all the properties from this object to the new object, and then also put this new property color onto it. So let's try this. Now when I move around and I click, it just changes color where it is. See that? I move around, I click, it just changes color. However, now when I move the mouse, the color gets reset. That's because we're not using this pattern in the other place where we're setting the state. So we take as input the previous state, and we return an object with ... previous state and the new X and Y. So now when I move, I click to change color, and then I move again. It has the color that was there before. All right, that's how you can use unidirectional data flow to add some interaction, which is a mouse follower that changes color when you click on it. To recap, our main function now leverages the second argument, which is an options object that has state and set state. State is an object that has some properties on it, which our code defines. It's an empty object initially. And set state is a function that takes as input a function that takes as input the previous state and returns a new state. This code here handles setting the initial state by testing if state.x is undefined. Then we call setState and pass a function that returns the initial state. And to make this a little bit more clear, I'll just use a variable called initial state, and we can return that from this function here. Okay, so that sets the initial state, and then we return, because the code down here depends on having state.x defined. And calling setState will actually change the state and then rerun the main function with the new version of the state. And when that happens, state.x will be defined, as with over 2, and then the code will pass that guard and go down into this logic here where state.x is used as the x property of our single entry in our data object. And we also use state.y and state.color. And this is honestly a little overly complicated since there's only one circle. So let me simplify this a bit by destructuring x, y, and color from our state object. And we don't even actually need this data array because there's only one circle. I'll just pass null like that. And then for cx, I could just pass in x, that comes from our state. For cy, I'll pass in y. For r, I'll pass in a hard-coded value of 20. And then for fill, I'll pass in color. And for this example, we don't really need the opacity part. Okay, so that simplifies that a little bit, and it still works. Okay, continuing the recap, when we move the mouse, we intercept this event and use D3 pointer to get at the correct x and y coordinates. We then call setState, passing a function that takes as input the previous state and returns a new object that contains all the properties of the previous state, namely color, and also new values for state.x and state.y. This is called an immutable update pattern. And if you Google immutable update patterns, there's this amazing page from Redux that describes these patterns quite nicely, including patterns for updating properties, patterns for dealing with arrays, like adding and removing items, updating an item in an array. And these are all super useful when you actually start using these patterns more often for various things. And this implementation also could be simplified. I think I'll just call this state, and we can use implicit return, so we don't have to even say return. But to do that, we need to wrap this object in parentheses. Otherwise, it doesn't work right. Okay, great. And now it all fits on one line. So that's how we listen for the mouse events and cause the circle to move around. And then, when we click, we generate a random color. And this is some AI-generated code that does some crazy stuff, but seems to do the right thing. All right, that's it. And the behavior is it moves around, it follows the mouse, and you can click to change it to a random color. And here's a challenge for you. Use this pattern to make something else respond to mouse events. For example, you could make a line that goes to the mouse and moves around. Or you could make a face where the eyes follow the mouse around. Or you could even try integrating this with an actual visualization by getting the mouse events and using scale.invert to get back to the data values and maybe showing the values on the axis or something like that. Good luck!